Everybody, welcome back to another fun and exciting Algebra 1 class. Today we are going to be in lesson 10.4. That's the lesson on histograms. And again, maybe this is a new one for you. Maybe you've heard of histograms before. My guess is that you've seen histograms before, even if you don't know exactly what it is or you've never heard the word before. Okay, so let's go ahead and jump into this. It's on page 357 in your book, page 357. I've got it written on the board here, and it's kind of defined in that first couple paragraphs. Histograms are modified bar graphs. So they're different than bar graphs, but they're based on a bar graph. So in histograms, you're going to see bars. The difference, I guess the one difference is the bars are all smashed together. So there's no gap, there's no break in between the bars. So they're all like smushed into one big bar, if you will, that has different peaks in it, different tops. This modified bar graph shows what's called frequency distribution. If you look at that in your book, frequency distribution says it's the list of numbers of data values within each class. What does that mean? Well, back when we were doing stem and leaf in the last lesson, we talked about the classifications. Those were the stems. So when we did the temperatures in Philadelphia, it was 30-something degrees most of the days. Well, that was the classification. 30s, it had to be in the 30s to be in that classification. Same thing going on here. Each separate bar is going to be its own classification. And then however much the distribution is within that frequency or within that classification is how high that bar goes. And then it says there, this is a more clear way to show the data than the stem and leaf. Sometimes the stem and leaf, well, always the stem and leaf is limited on what it shows. The stem and leaf is just focused on the data, just focused on the numbers. That's it. This is more focused on the visual effect of creating something that somebody can see. The other thing is that this does a good job at is it can incorporate more. Like if you had a stem and leaf with like 300 or 500 entries into the stem and leaf, all of a sudden your stem and leaf would get big and hard to read again. This can handle bigger numbers, more categories, things like that. So just a little different, but it's handling the data basically the same way that the stem and the leaf did. Okay. All right, let's take a look at this one. These are ages of people in this church. It's in your book. They go to, it says Heritage Baptist Church, okay? So here's the people and here's their ages. So if you are 0 to 9, so you're in the kiddie class, there are 36 kiddies in their church. Between 10 and 19, kind of the teenage years, there's 43 of those people. 20 to 29, that's me. Why are you laughing? Okay, I'm not 20 to 29 anymore. I used to be. Many, many moons ago, I was 20 to 29. But there are 52 of those. 30 to 39, we're getting closer to me, okay? Still not there yet. 41 of those. 40 to 49. That's me. Yeah, that really is me this time, okay? There are 34 of us. 50 to 59, 32, 60 to 69, there are 44, 70 to 79, there's 45, 80 to 89, there's 10, and check out these people, these guys, I love them, they're dedicated, they're still going to church. 90 to 99, there's 3 of those people in that church, okay? Now, this would be like on an average Sunday, they just took the ages of everybody in the church. Well, if we started putting that information on a stem and leaf, we would have a bunch of stems. We would have 10 stems. And then look at how many we'd have, like on the 20 to 29, there's 52. So we would have 52 leaves. A lot of data. it would be a little confusing looking at a stem and leaf. It could give you some good information, but this would be a lot for a stem and a leaf. So that's why we're going to use this histogram here. All right, what are the ages at Heritage Baptist Church? What does this look like on a histogram? Notice it has bars. This is a vertical histogram. You could also have a horizontal histogram. And each little segment here, okay, you can kind of see it, is divided here by a little bit of a darker line on the screen. So I'm adding a little bit to that division so you can see the division just a little bit better. Notice where the divisions are. The divisions are at key intervals. Remember, those are the intervals that we used on the stem and leaf. Categories: 0, 10, 20, 30. Okay? Benchmarks. Big categories. All right, and then going up, what is this section over here going up? That's the frequency. Remember, that's what we were talking about. How many times something happens is the frequency. So how many times did 0 to 10-year-old happen in the church? How many of those were there? Well, there was 30, and then we have, that's the major grid line is 30 right there. And then we have the small grid lines are 2. So 2, 4, 6, so 36 is what it looks like. If we go back up here, there's our 36, okay? And so when you're drawing this, you would just draw that, and then you would color it in if you like, and then you go to the next one. And you can draw different colors if you want. You can give each one a different color, make it look pretty. Or you can keep it the same color, doesn't matter. And then you just keep coloring them in, and you keep drawing them as you go. What are you drawing? You're drawing this information right here. So that one goes to 41. That's where I'd stop that one, and then you color it in, okay? And then if you want to make them all the same color like they did, fine. If you want to change the color like I was changing the colors, that's fine too. It doesn't matter how you draw your histograms. The one thing that you do have to do with the histogram, and the reason why is because this, the reason why there's no gaps in between these. So why don't they have like a gap in between these two? Why isn't that like a blank space right there? Because there's no gap in between the ages. In other words, there's 50 to 60. There's no gap between 59 and 60. That's just it's crammed together. And so histograms are bunched together, and that's the difference between a histogram as far as when you look at it visually, it looks different than the bar graph. Immediately you see that it's different because they're all crammed together. Bar graphs you don't push together. Why not? Because they're bar graphs and they need to look like bar graphs. Histograms you do push together so that it looks like a histogram and so that people know what they're looking at when they see it. Now, you can answer questions about this. I could ask you questions like, what decade has the most people in the church? And you would say, well, the 20s, because between 20 and 30, look, they go up to 52 or whatever that was. Which decade has the least people in the church? This is sad over here, but this is a reality of life, right? Is the 90s. They have the least people in the church. There's only 3 people in their 90s. I could ask you questions like, what is the difference between the 60s and the 70s? And so, wow, that's a pretty small difference. Looks like maybe just one person different, maybe 2, based on that information. So you could just look at this. You don't have to go back here. So if we go back to look at the 60s and 70s, yep, there's only one person different between the 2. And you could see that here on the chart, because the one goes to 44, the other goes to 45. So all kinds of different things you can do there with those histograms. You can look at them, tell a bunch of information. You don't even really need the numbers. We had the chart so that we could build the histogram. Make sure that you always put a label on it. Make sure that you always have titles of what your axes are. This one is the age axis. This one is the frequency axis, so that people know what they're looking at, the up and down. And make sure that you're labeling them just so people can understand. Use grid lines. That helps people to see it. If you don't use grid lines, then it's hard to follow it over there. It's hard to see what that's actually talking about. Okay, one more thing here that I want to talk about before we end this lesson is on page 460. Page 460, symmetric and asymmetric. Some people might say asymmetric. I say asymmetric. It's kind of like whichever you want. I follow the rules of grammar right there, though, because it says there's a vowel within one, and so it makes that long sound. So I say asymmetric. But probably if you look in the dictionary, both of them would be acceptable. I've heard both of them. So asymmetric, asymmetric doesn't really matter which way you say that. What are they? Well, one is when something is in balance, and the other, asymmetric, is when something is out of balance. Page number 360, you'll see there's like a little pattern. So it goes up and over and up and over and up and then down and up. Okay? And this is symmetrical. Why is that symmetrical? Because everything is balanced out. So this would be balanced or symmetrical. And when your histogram looks like that, it would be a symmetrical distribution. Then there's asymmetrical when there's no real rhyme or reason to the chart. Okay? It just kind of does its own thing. It's asymmetrical. It's unbalanced. There's some that are tall, some that are short, okay? And there's no balance between the two. So symmetrical, asymmetrical, balanced, unbalanced. It is important that you understand that because that's not just a histogram term. Symmetrical and asymmetrical is like an art term. It's a design term. It's a building term. It's a term that you're going to see a lot. It's in geometry. It's everywhere, okay? So make sure that you know those two words and their difference, okay? Symmetric, that means it's balanced. Asymmetric means it's unbalanced. All right, that's about all I have for you for that lesson. There's lots of practice there, exercises that you can work on. Make sure you scroll that back if you missed anything. Take a look at it about how to build or how to read histograms. All right, we'll see you later. Have a good one. Bye-bye.